Before we get into an actual example, let's first talk about what a confidence interval is. Imagine that we wanted to find the average number of hours athletes spend on athletic activities per week. Well, if we were to take a sample of athletes and ask them, we could mark down the number of hours they spend on athletic activities per week. Then, based on that sample, we can find an average or a mean. However, what if we were to do this experiment again? What if we were to ask another set of athletes the same question? Well, it's very possible that we would get a different value for the average. So therefore, what we do is we add and subtract a margin of error. Okay, that's your margin of error. So we add and subtract a margin of error so that if we were to do this experiment again, we can be confident that it's going to fall between two values. We know that x is going to fall somewhere between the average minus that margin of error and the average plus that margin of error. So this is what a confidence interval is. It's an interval of numbers or a range of numbers so that if we were to do an experiment a second time, we can be confident that, to a certain extent, that our sample statistic is going to fall within that range of numbers. Now let's talk about the level of confidence. The level of confidence C is the probability that the interval estimate contains the population parameter, assuming that the estimation process is repeated a large number of times. When we have a large sample, specifically our number has to be bigger than or equal to 30, we're going to have approximately the normal distribution. So this level of confidence is the area under the standard normal curve between two critical values, and we denotate it as Z sub C. Okay? So that would be the level of confidence. And in this class, mostly we'll see a confidence level of 90%, 95%, and 99%. Now there's a table. In your Z table, you'll see a little area that actually has your level of confidence along with those critical values. And I'll just list them out here so you can see them. So when we're dealing with a 90% confidence interval, our critical value is 1.645. If it's a 95% confidence interval, our critical value is 1.96. And if we're dealing with a 99% confidence interval, our critical value is 2.575. And we're going to use these in our calculations of the margin of error. Construct the confidence interval for the population mean. Your confidence interval is going to be 0.90 or 90%. X bar is 12.3, sigma is 1.5, and n is 50. So let's list out the formula for the margin of error. Okay, here's our equation for the margin of error. And our confidence interval is going to be x bar minus this margin of error, x bar plus this margin of error. So first let's calculate the margin of error. Since I'm dealing with a 90% confidence interval, I go and look at my table, table 4, and I look at where it has the critical values for the confidence level of 90% or 0.90, and that is 1.645. Standard deviation is 1.5 all over the square root of n, which is 50. Okay, this calculation here is 0.212. And this is equal to 0.34, which is approximately equal to 0.3. And the reason that I rounded it to the nearest tenth was because I looked at my x bar and I rounded it according to the same decimal points as it has in your average. Now, let's calculate the actual confidence interval. So your X bar is 12.3. The first one you're going to subtract the margin of error, and in the second one you're going to add the margin of error. So we have 12.0 and 12.6. Use the confidence interval to find the estimated margin of error, then find the sample mean. A government agency reports a confidence interval of 26.2, 30.1 when estimating the mean commute time in minutes for the population of workers in a city. So if we were to look at this on a number line, you could think of it as your average being there, 30.1 being on the right side, 26.2 on the left side. Now we know the distance here is equal to the same distance here. That's the margin of error. So if I find the total distance between these two numbers and divide by 2, I'll find the margin of error. So I have 30.1 minus 26.2, and I'm going to divide this number by 2. That gives me 3.9 divided by 2, which equals 1.95. So the margin of error is 1.95. Now, I want to calculate the sample mean. What I need to do is think about how each of these numbers is calculated, the 26.2 and the 30.1. The 26.2 is calculated by saying X bar minus the margin of error. So I could say this is X bar minus 1.95. That's going to be equal to 26.2. So here I can see I just need to add 1.95 to both sides. And I find that X bar is equal to 28.15.